So a scatter plot will be a really easy tool to help us visually determine whether we see a correlation. And what we can observe in these different pictures is when we have what's called a positive correlation, we notice there being, say, an upward trend, that as one variable increases, the other variable also increases, right? So in this case, looking at these two variables, they have one variable x is the years of education, and the other variable y is the salary. And so we notice here the upward trend that as the number of years of education increases, we also notice that the salary increases as well. So these two variables are moving in the same direction. When we have a negative correlation, the two variables are opposing. So for instance, here when we look at the hours spent sleeping versus the hours spent awake, we notice there's an opposite effect on one another. As one variable increases, the other variable decreases. So we notice that graphically there's this downward trend. So in this case, the variables move in opposite directions. And when we have no correlation, we don't notice any meaningful relationship that we can visually see. For instance, here it looks like in this case, the variables hours spent sleeping and shoe size don't appear to have any correlation at all, because there's no upward or downward trend. It's just sort of a scatter plot with no particular shape. So we don't really appear to have any relationship between these two variables. So we'd say there's approximately no correlation. Now, to test for a linear relationship, we'll be testing for linear correlation, where we're going to see how well the data fits to a straight line. And there's two important features that we have when we're looking at a linear correlation. So the strength, in other words, is it strong versus is it weak? So strong means that the data we expect to see kind of fits very closely with a straight line. Versus weak, maybe it's a little bit more scattered, but doesn't quite match up exactly with a straight line. But the closer the data is to a straight line relationship, the stronger the correlation. So for instance, here we get a bunch of dots that are maybe closer to a straight line compared to here, even though there's this upward trend. Maybe the dots here are a little bit further away from that line. So here the strength is determined by how closely the data fits to a line. Versus now the direction would be depending on whether it's moving in an upward or downward direction. So we saw before that when we have the two variables are moving in the same direction, then we have a positive correlation. Versus when the two variables are moving in opposite directions, then we have a negative correlation. So the same idea as before, if they can appear to be fitting a straight line but moving in, oh sorry, that looks like negative to me. So if they appear to be moving in a straight line but in the upward direction, that would be positive, versus if they appear to be moving in a straight line but in the negative direction, that would be a negative correlation. And again, the idea here is if it appears to fit a straight line, then maybe that would be a linear correlation. And the strength of our linear correlation is something that we can measure, and we'll look at how that's computed, but for us it'll be called the Pearson correlation coefficient. And it'll be represented by the letter R. And when we're looking at the letter R, it has some important properties. For one, it's always going to be a value between -1 and +1. And when we have a value of 0, that corresponds to there being no correlation at all, versus a value of 1, +1, we would have or something close to +1 would be a strong positive correlation. And if I have a value close to -1, then we have a strong negative correlation. And something that's maybe close to 0, sort of in this region around 0, we would say is either a weak correlation, or if it's really close to 0, we would probably just say that there's no correlation. Okay, and an important idea is that we oftentimes can make this mistake of supposing that if we observe a correlation, then there is a causation relationship. But in general, we have to be very careful about that, because correlation does not always imply causation, but rather there is just some relationship between the variables. Okay, and whether or not one variable causes the other variable to change or be affected in some way, that's something that has to be tested explicitly using very careful controlled experiments. But just observing a correlation does not imply that there is a causation relationship. So let's look at some different scatter plots here and try and determine what kind of correlation we observe. So for each of these, we'll try and choose whether it's a linear relationship, a non-linear relationship, or no relationship. We'll then determine if it's going to be a perfect line, a strong correlation, moderate, or weak correlation. And then we'll try and see if it's a positive, a negative, or no correlation. And then we'll see if we can try and match each of these graphs with a particular R coefficient. So when I look at the first graph here, I clearly see that it fits pretty closely to a line with a positive slope. So I'm definitely going to say this has a positive linear so it's a linear relationship, and it's positive. And because it fits pretty closely to that line, I'm going to say it's also strong. And let's compare that with this one here. Again, if I try and draw a line through the data, it fits pretty closely to a line. In other words, we see this overall upward trend in the data. But notice it doesn't fit as strongly as the data here, but it still fits pretty well. So I'm going to say that this still has a strong positive linear correlation. But I would argue that maybe this one is not as strong as the previous one. In other words, this one is stronger, and so I can imagine that this one would have a larger correlation coefficient than this one. So if I'm looking at the different options here for the correlation coefficients, I'm going to pick the larger one to go with the one that appears to have a stronger correlation, and the smaller one will go with the one that appears to have a slightly less strong correlation. So for for these different R values, well, these are the only ones that are positive, so I'm going to assume those go with these two graphs here. So I'm going to put the larger one with the one that appears to have a stronger correlation, and then the smaller one will go with this one. When I look at this graph, it doesn't appear to me to have any linear relationship at all, because the dots here don't appear to be increasing or decreasing in some predictable way. So this appears to me to have no correlation at all. So I'd say there's no relationship. So I can't say if it's strong or weak. Certainly no correlation. And so I'm going to say that there's, well, I wouldn't say that there's no R value here, but a really small R value in this case. So I'm going to pick the smallest one here to go with this. So if there was a relationship here, it would be really weak. Because you can imagine maybe you could find a line that fits the data, but it's going to fit it very loosely. Now looking at the next one, I definitely see a downward trend here. And same with the next one. These both kind of have a downward trend. And so for both of these, I'm going to say that there is a strong negative linear correlation. And the one that appears to be stronger would be the one that fits more closely with the line. So I would say this one here appears a little bit stronger than the other one, since the data here appears to fit more closely to the line than the data over here. But in either case, they both fit pretty closely, so I'm going to assume they're both strong negative linear correlations. Which one has the bigger R value? Well, they're both negative correlations, so they're going to correspond with the negative R values. The one that's closer to -1 will be the stronger one. So -0.89, I'm going to put the one that looks a little bit stronger. And this one would be the other value of -0.735. Because here it looks maybe a little bit less strong than this one. Looking at the last graph here, it looks to me like maybe it's linear at sort of the one end here, but because here the linear relationship doesn't really apply to the first part of the graph, then maybe there is a nonlinear relationship. In other words, maybe there's a nonlinear curve that can describe the data here. And so in this case, I would say that this is a nonlinear relationship. So perhaps some nonlinear correlation, and in this case, because we're not trying to fit a line to the data, we're not going to compute an R value. So I'm going to say that there's no R value here.